Macroscopic properties. Properties associated with macroscopic system. It is properties associated with macroscopic system. What is macroscopic system? System constituting large number of molecules. Okay, constituting large number of molecules. It's called as macroscopic system. So the properties associated with this macroscopic system is called as macroscopic properties. Okay, example: pressure, volume, mass, etc. These macroscopic properties are divided into two types: extensive properties and intensive properties. So what is extensive property? What is meant by extensive property? Properties of the system which depend upon the quantity of matter contained in the system. Okay? Properties of the system which depends upon the quantity of the matter in the system is called as extensive property. We'll take examples. Examples are mass, depends upon the quantity of the matter. Okay. Next, another one, heat capacity, volume, then enthalpy, internal energy, etc. are examples of extensive property. Okay. Next, second one is intensive property. That is properties of the system which is independent on the quantity of the matter. Okay. Properties which are independent. On the quantity of the matter. Such properties are called as intensive properties. Okay. For example, temperature, independent on the quantity of the matter. Then pressure, density, etc. Independent on the quantity of the matter of the system. These properties are independent on the quantity of the matter of the system. Then viscosity, etc. are examples of intensive properties. Okay. Next, state of the system. So, the condition at which the macroscopic properties of the system have definite value. Okay. Condition at which the macroscopic properties of the system have definite value. Okay. So at STP, that is a condition at which the pressure, temperature all are having standard values. Okay. At STP, standard temperature, pressure. So temperature and pressure is having a definite value. At that condition, the system is said to be the state of the system. If any of the properties changes, what happens? State of the system also changes. Okay, so a process occurs, the state of the system changes. A process occurs means state of the system changes. Okay, so the measurable properties required to describe the state of the system is called as state variables or state functions. Okay, measurable properties, for example, temperature, pressure. Measurable properties required to describe the state of the system. Is called as state of the system is called as state variable or state function. Okay, state variable or state function. Example, temperature, volume, pressure, etc. Okay. State function and path function. In the case of state function, value of the state function depends only on the initial and final state of the system. Okay, that is, these properties depends upon initial and final state of the system and never depend upon the path through which they pass. Okay, or the path through which the change is carried out. So state function, the value of state function depends upon the initial and final state of the system and never depends upon the path through which the change is carried out. Example. Take some examples. Examples are pressure, volume, then temperature, internal energy, etc. Pressure, volume, temperature, internal energy, etc. Okay, are examples of state functions. Okay, now next, what is path function? The value of the path function depends upon the path through which they carried out. Okay, depend upon the path followed are called path functions. Okay, properties whose values depends upon the path followed are called as path functions. Examples, heat and work are examples of path functions. Okay.